Thanks for the update, Pietro. Some great work is really happening there. Speaking of updates and patches can be the stuff of nightmares for system admins working with Kubernetes. Let's bring back Alex Jones to talk about some ways to reduce complexity so that you can manage your own digital estate with less complexity and less late night phone calls. Take it away, Alex.
Thank you, David. It's a real pleasure to be here and talk about Kubernetes today. I'm excited because this next 15 minutes or so, I'm going to dig into why we think that Canonical Kubernetes is a great way to overcome some very real operational challenges that is really relevant to this whole event. So first and foremost, I want to introduce myself. I'm an engineering director here at Canonical. My name is Alex. I also work on the tag app delivery for the CNCF, and so I see a lot of problems that come through, a lot of well-trodden paths that we see when engineers are trying to solve things in production and they're working with K8s at scale. And then lastly, I'm part of the open feature sandboxing group in the CNCF, which is a project that I've been helping to push along and to innovate on in the feature flagging space for infrastructure. So what are we doing here today? As I said, Canonical Kubernetes is something that we're really excited to share to a wider audience. And I think what really excites me in particular is about how it's a solution, not just a product, right? It's not just, here's a distribution, away you go. It actually solves some real challenges that people have. I mean, I've worked previously at 4 or 5 large companies managing clusters of many hundreds, if not thousands of nodes. And so I can really empathize with a lot of the tough stuff that people have to put up with in K8s. Specifically, one of the reasons that Canonical cares about Kubernetes is that if you look at this little illustration, Ubuntu is the de facto operating system on a lot of these providers. Even if it's a hyperscaler, it could be your mom and pop shop, it could be your own infrastructure, it could be a Raspberry Pi. Ubuntu is typically what people use, and we're really proud of that fact. And we guard that with a real sense of responsibility as well, because we need to make sure that Ubuntu is the best operating system it can be. And so that's really where it started, but where it is now is an evolution of that. And we really think that you might have Ubuntu as your substrate, but running that cluster on top is challenging, right? Because, for example, you provision something and that provisioning will drift away from the thing that you deployed. Let's say that I'm using kubeadm, I put it on a host OS, I then need to do an upgrade of the OS, kubeadm, and maybe some other bits and pieces. Where does all that stuff get kept? How do I make sure that that operational knowledge is captured in a way that is reproducible? Now, there are provisioning tools out there. I won't name any specifically, but a lot of these will either do one of two things. They either are a push and a capture of state, or they are a reconciliation loop that runs remotely and you kind of don't really get involved at all. So there's some real challenges, even in getting started with trying to provision your cluster and make sure you know what's going on. The second part of this, that's probably the real keystone to what operational complexity is all about, is updating and upgrades. I mentioned upgrading Kubernetes or the host OS. How do you orchestrate that across your cluster in a seamless way whilst thinking about tolerations and disruption budgets and making sure that there's no impact on your running workloads? Upgrades and updates are super tricky. When somebody says, hey, there's a critical vulnerability, a CVE that's come in, on average, I would say there's definitely an overhead before you can even think about introducing that change, because many complex systems, you've got to think about how does that impact and build into our pipeline. If you're consuming a base OS or you're consuming a Kubernetes distribution, you've got to go off and check that they've actually made that change before you can then go and upgrade. And the final piece that we see time and time again is this idea that you have cloud provider specific logic. So whether this is an ingress controller, whether this is a storage class, whether this is something, an API that you're using for your object storage, having these all specific to a cloud provider is really tricky. Now, regardless of what people say, even in Kubernetes, you'll have to add annotations for that cloud provider. You'll have to give it a configuration to that cloud provider. They have different types of credentials, they have different types of access rights. And so it's a real head scratcher for a cluster admin when developers are using one type of implementation and then they then have to deploy it on another implementation. And if you thought that was tough, running this on multiple clusters is even harder. Imagine everything I just said, plus these things, right? We haven't even gone to mention security standards. Are you running on a FIPS conformant environment? Is it CIS conformant? Your Kubernetes might be, That doesn't mean your host OS is. CIS conformance is across the entire stack. What sort of security policies are you putting in place? How does your recovery strategy look? Access, observability, hybrid, your hybridization. All of these things are really tricky to get right. And also, a lot of this becomes a homegrown approach, right? You'll have an answer to each question independently. Each one of these might be a different vendor tool. One of these might be proprietary. One of these might be semi-open source. One of these might be AGPL2. One of these might be a subscription for a SaaS. Then keeping track of all that, it's just crazy complex. And so I think that one of the things that you see DevOps engineers and cloud platform engineers actually doing these days is becoming managers of inventory more than anything else. So as I've described, there's this whole spectrum of operational needs, from somebody who just needs to have the auto upgrade path sorted out to somebody who needs to manage a fleet of K8s clusters plus virtual machines plus edge devices as well. And so part of my job, my team's role, is to understand how to build solutions to decrease this complexity. How do you look at a project like Kubernetes and actually say, well, to make value out of this project, we're going to decrease complexity? What do you pick to tackle first? So I want to introduce both of our K8s offerings. MicroK8s is a CNCF conformant Kubernetes. That basically means that it has the rubber stamp of being, this is the Kubernetes API that we serve. What really pulled me towards MicroK8s before I even started working at Canonical was this idea that it was super quick to install, snap install MicroK8s. And I think that really doubles down on this ideology that it's a developer first zero ops platform. We've got a bunch of other capabilities, and I'll touch on some of those. But just being able to install K8s in a one-liner and uninstall it if you want to gives me a real sense of confidence. Like if I want to do an installation of a browser, I just do a snap install or snap remove. It feels like it's really discrete, and I can just get rid of it or I can upgrade it, and I feel like I'm in control. Whereas if I'm having to install this sprawl over 8 machines, it's a stressful environment because then I know I can't unplug my router, I can't change things up. So MicroK8s was predicated on being simple. Now, to mention the other things, like it has an add-on ecosystem where you can turn on and off Prometheus, you can turn on and off AI/ML, and we've done all the legwork, so you don't need to make it work for this implementation. It just works and scales up, scales down, it scales left, right. And the last thing I'll mention is that we support a ton of flavors, right? If I can't run it on something, then I'll think to myself, well, what can, right? So we have to be competitive here, but we also need to understand that in the future, people aren't going to be working on homogeneous aggregated infrastructure or HCI. People are going to be working on disaggregated infrastructure. So they'll have some things in data centers, some things in edge, some things on ARM, some things on Power 9, and they might want to cluster those all together. And so we support all of that. And so what you can see is the MicroK8s use case here is really trying to distill a lot of those initial operational challenges into a set of simple workflows. The next thing I want to talk about is for folks who they like all that, but they need to take this a bit further. They need to be able to understand how to run a VM, how to spin it up, stand it down, install a thing to do something, right? You might be a DBA who wants to run a MySQL database on AWS, on GCP, on Oracle Cloud. You suddenly got a problem because either you write a whole bunch of provisioning scripts in HCL for certain tooling, or maybe you have to figure out how to write a shell script that then allows you to call the cloud provider API. So you're creating all of this overhead, all this bureaucracy, all this stuff you've got to maintain. And so one of the flagship products that we leverage with Kubernetes is Juju. And part of Juju is something called the Charmed Operator Lifecycle Manager. And this OLM is effectively a framework that you can build around your application workloads, and it gives you a level of data insight. It gives you this concept of relations, and it gives you a concept of modeling. And I'll go on to explain a little bit more of what I mean. I've also included a QR code, so if you're curious, just take a snap of that, and you can jump right in and see what it's all about. Charmed K8s is the concept of, what if I could model all of this stuff, right? What if there was a language ubiquitously that I could use? Or what if there was a CLI that I could use in a single entry point to drive all of this? So Charmed K8s is effectively taking that value prop of MicroK8s, but working it in a Juju way with charms. So what I could describe is I want a Kubernetes charm installed, but I want to install it a bit over here, a bit over here. I want a database that's running over here. Now with Juju, you're able to express that desired intent through charms and through bundling charms. And what's really exciting is that with charms, you can actually add a charm to the hub, right? So somebody else can benefit from that. Like there are projects such as Ansible Galaxy, there's projects such as the Snap Store as well. Well, Charm Hub lets somebody write a charm and everyone else can benefit from it. And equally, they can then go back and make their own adjustments and contribute back to that project. So Charmcase is really solving for that idea of how do I not only provision, but manage this stuff. What's really exciting is that you can do all this management and then you can upgrade really easily by telling the charm that the bundle has had an increment on it, and away you go. You can install the next version. Because all of this stuff predicates on snaps as well, the snap system is further a feather in the cap of applying nightly revisions. So the kubelet has a CVE, the snap upstream channel will push down the latest revision that gives you that security patching. So again, this is all part of that story of making things super easy. So if you were to compare, what is microK8s and Charmk8s, I would say that microK8s, to its namesake, is small, but it's also small in terms of it solves a subset of problems. You're able to get up and running. You can have integrated plugins and add-ons. You can scale it out if you want. Whereas Charmk8s gives you this data-driven approach of I've got some business logic and microservices I need to keep up that are critical, and I want to express those as a sequence of charms. And these charms enable them to interact with each other in an automated way. And I think this is a really interesting proposition because I don't see it done anywhere else to such a degree. And what these things actually do is they solve problems, right? These are solutions for the following things that we see come up time and time again. I don't need to go through each one of these. I'm sure a lot of these will look familiar, but two of the real, I think, game changers here is the way that in Juju, growing to meet demand means that if I have a VM running that MySQL database, I can scale the VM with Juju, but I could also scale the K8s cluster independently. There's two different things, right? Using the same substrate, the same CLI, the same set of controllers and models. And again, that applies to the multi-cloud story. Disaster and recovery, microK8s has distributed block storage built in it. So we're thinking about, in both of our distributions, how do we cater for that entire spectrum of operator needs? If you're interested in this stuff, go check it out. We have no agenda here. This is an open source project. We love contributors to these things. Take it for a spin. Tell us what worked for you. Tell us the things that you have as a real set of bugbears when you're working with Kubernetes every day. I hope you enjoyed this. I really, really was excited to give this talk, and I hope that I've done some justice to it. Back to you, David.